Hello everyone, welcome to the video on voltage and current division rule. In this video, we are going to see how voltage and current will divide in a circuit that contains more components. There are two main rules involved here. One is the voltage division rule and the current division rule. If you see here the first one, we have written voltage division in series, and here it is written current division in parallel. So one thing that we need to note is that when two components, for example, let me consider two resistors. When two resistors are connected in series, then the voltage will be different for each and every resistor, but the current will be the same, which means I'm saying in a series connection, the current will remain constant, but voltage will be different for both the resistors. If there are three resistors, voltage will be different for all the three resistors, but current will be the same among components that are connected in series. The second one is current division in parallel. When two or more components are connected in parallel, the voltage will be similar for all the components that are connected, but the current will get divided among the elements, and therefore we mention the rule to be current division in parallel. So in a series connection, the current remains constant for all the components, but voltage gets divided. In parallel connection, the voltage remains constant whereas the current gets divided. Now let us start with the voltage division rule. So as I said earlier, let us consider two resistors that are connected in a series combination. When two components are connected in series, as I told previously, the current remains constant for both the resistors, but the voltage, the total voltage V gets divided as V1 and V2 between the two components. So, for example, if I calculate the voltage V1 across R1 and V2 across R2, then according to voltage division rule, the voltage across one resistance is equal to the total voltage into value of that resistance, which means the resistance where I am measuring the voltage divided by sum of the individual resistances. For example, let us consider here, I am measuring V1 across R1. Then according to the rule, V1 voltage across one resistance must be equal to, it is the total voltage. So the total voltage here is V into value of that resistance. So at which resistance I am measuring? So that resistance means it is R1 where we are measuring divided by sum of the resistances. So it is R1 plus R2. Similarly, if I measure the voltage across resistance R2, so V2 will be equal to the total voltage V into that resistance. So which means it is R2 divided by sum of all the resistors in the circuit. So all the resistors is R1 plus R2. So I hope you're clear with what we have written. If there are three resistors, we will be measuring V1, V2 and V3 and it keeps going on. So this is not only applicable for DC circuits where resistors are present, we can apply the same rule to AC circuits also. So when we talk about AC circuits, we don't talk only about resistance but we talk about impedances. Impedances are nothing but it is a combination of R, L and C. So when we talk about AC circuits, instead of R1, we'll represent the impedance as Z1 and instead of R2, we'll represent the impedance as Z2. So the rule will be V into Z1 by Z1 plus Z2 and V into Z2 by Z1 plus Z2. So for DC circuit means it contains purely resistance values. For AC circuit, it will be combination of R, L and C and that is what we represent as impedances in your circuit. So when components are connected in series, have in your mind the voltage gets divided and the current remains constant. That is why we have voltage division rule in a series connection. The next rule is the current division rule. When two or more components are connected in parallel, then the current gets divided among the components as I1 and I2, whereas the voltage remains the constant. Then According to current division rule, the current across each of the resistor can be measured as the total current into value of the opposite resistance by sum of individual resistances. So now let us see how to measure for this particular circuit. So if you want to measure the current across R1, then I1 will be, it is the total current. So we represent it as IT here. So total current IT into the opposite resistance where the current gets divided. So what is the opposite resistance where the current gets divided? This resistance is, it is R2. So it is IT or just I into R2, which is the opposite resistance, by sum of the resistance is nothing but R1 plus R2. Similarly, the current across the second branch will be I2 is equal to, so this is I2. I2 is equal to the total current IT into, for this the opposite resistance is R1. So IT into R1 divided by the sum of the resistors is R1 plus R2. So in voltage division rule, the rule is total voltage into value of the same resistance by sum of the resistances. In current division rule, the formula is the total current into opposite resistance by sum of the resistances. So DC circuit means it is only R. When we go for AC circuit, we will be using impedance, which will be represented as Z. It is similar to what we saw in the voltage division rule. Fine. Now using the concept that we saw, we will try to solve this problem. The question is, when a 6-volt source is connected across A and B in the network shown, find the total resistance between terminals A and B, the total current drawn from the source, the voltage across the 3 kilo ohm resistance, and the current through the 4.7 kilo ohm resistance. So let us see how to solve this problem. Now let us see the solution for this problem. So we have read the question already. Now first let us start to calculate the total resistance between the terminals A and B. So here we have the terminal A, here we have the terminal B. I need to find what is the total resistance of this particular circuit. Now I'm going to modify this circuit and draw. If you see A, it is connected to the upper part of the circuit, B is connected to the lower part of the circuit. Instead of drawing the circuit in this way, we are going to modify the circuit and draw it like this. It is the same. The 10 kilo ohm that has appeared here, we have just pushed it backward and now it has appeared here. A is connected to the upper half of the terminal, B is connected to lower half of the terminal. It is again similar here. A is connected to upper half, B is connected to lower half. So the diagram, the circuit in the previous slide, we have just modified and drawn the circuit in this way. Now let us start to find the total resistance in this circuit. If you see here, this 5 kilo ohm and 4.7 kilo ohm are connected in parallel. So parallel in the sense both ends of the resistor are connected. So we call this to be a parallel combination. So in a parallel combination, the equivalent resistance is given by R1 R2 divided by R1 plus R2. I'll try to write if possible. So the total resistance is given by, it is R1 into R2 divided by the sum. So it will be R1 plus R2. So this has to be 5 into 4.7 divided by 5 plus 4.7. So if you see here, we have found out the total equivalent resistance 5 into 4.7 by 5 plus 4.7, it is going to be 2.4227 kilo ohm. So after finding this, if you see, this 4.4 kilo ohm and 2.4227 kilo ohm are in series combination. Series means what do? We add up the two resistances together. So we can see that 4 kilo ohm and 2.4227 kilo ohm are in series. So therefore we get it to be 6.4227 kilo ohm. So now we have three resistances in total, 10 kilo ohm, 3 kilo ohm. These two in series, we have combined it to be 6.4227 kilo ohm. Now look at these three resistors. All the three are connected in a parallel combination. So in the next step, we are going to find the parallel combination. So it is 1 by R1 plus 1 by R2 plus 1 by R3. So or we can use the equivalent resistance formula for three resistors as the formula is R1, R2, R3 divided by R1 into R2 plus R2 into R3. I'm sorry for the bad handwriting. I'm not able to write it using a mouse. Plus R1 into R3. You can use this formula also to find the equivalent resistance when three resistors are connected. So two resistors means it is R1 R2 by R1 plus R2. If three resistors means it is R1 R2 R3 by R1 R2 plus R2 R3 plus R1 R3. So three resistors are 10 kilo ohm, 6.4227 kilo ohm and 3 kilo ohm. And when you find out the total equivalent resistance of our circuit is 1.6977 kilo ohm. So this is the solution for the first subdivision. The total resistance present in our circuit is 1.6977 kilo ohm. Fine. So this is the total resistance that is present across the terminals A and B. Right? And the question, if you see in the starting statement, they have mentioned that a 6 volt is connected across the terminals A and B. So here we have connected a 6 volt input across the equivalent resistance. Now the second subdivision, we are asked to find the total current across the circuit. Now total current means we have the total voltage of the circuit, we have the total resistance of the circuit. Then according to Ohm's law, we know that V is equal to I into R, or I can be calculated as the total voltage by total resistance. So the total voltage is 6 volt, the total resistance across the circuit is 1.6977 kilo ohm. When you divide these two values, we will get the total current to be 3.5342 milliamperes. So this is the solution for your second subdivision. Third subdivision, we are asked to find the voltage across this 3 kilo ohm resistor, and here we had the terminals A and B across which we have connected your 6 volt power supply. Now if you see this 6 volt supply and the 3 kilo ohm are in a parallel combination. The one end of voltage source is connected to one end of resistor. The negative end of voltage source is connected to negative end of resistor, which means these two are connected in a parallel fashion. And according to the voltage division and current division rule, and according to the general analogy in circuits, voltage will remain constant in a parallel combination. So across 3 kilo ohm also the same voltage is going to flow. So the voltage is going to be the same 6 volts across the 3 kilo ohm. Now the fourth subdivision, we are asked to find the current through the 4.7 kilo ohm resistor. So across this 4.7 kilo ohm, we need to find what is the current flowing through the particular resistor. So to find the total current, let us try to reduce the circuit in a certain way. So we know that this 5 kilo ohm and this 4.7 kilo ohm are in a parallel combination because both the ends are connected. So which means I'm going to find the parallel combination. So it is 5 into 4.7 by 5 plus 4.7. So this is 2.4277. Here this 3 kilo ohm, it remains the same here. This 4 kilo ohm, it remains the same here. Now if you see, this is parallel, so voltage is going to remain the same. But these two are in series. So in series, we know that voltage gets divided. So this 6 volt, here we will assume the voltage to be V1 volt. Here we will assume the voltage to be V2 volt. So I'm going to find what is the voltage across this particular resistor combination. And current can be easily found out by using Ohm's law, where I is equal to V by R. So R, I know what is the value of R already. We have the voltage source already, which means I can be found out directly as V divided by R. If current source is given means we can go for the current division rule. But since voltage source is given, we will try to apply voltage division rule, find what is the voltage across this resistance, and then by applying Ohm's law, we will find the current across this particular resistance. So the next step, first what we are going to do, I'm going to find what is the voltage across this resistor combination. So what is the voltage division rule? It is the total voltage, which is 6 volt, into this resistor, the same resistor which is 2.4227 divided by sum of the resistors. So sum of the resistors means it is 4 kilo ohm plus 2.4227 kilo ohm. So in the next step we have V2, we are finding it to be total voltage into across which I am measuring. I am measuring across this particular resistance. So it is 2.4227 kilo ohm divided by sum of the resistors is 4 plus 2.4277. So it is 6 into 2.4277 by 4 plus 2.4277, and we are getting the voltage across the resistor combination to be 2.2633. So across this total combination, this is also V2, this is also V2 because they are in parallel. In parallel, the voltage remains same. So across 4.7 also, the voltage is 2.26. Across 5 kilo ohm also, the voltage is the same 2.26. Now I need to find the current across this 4.7 kilo ohm, which means I need to find what is the current here. So we know what is V2, we know what is the resistance value. So I will be V divided by R value. So I is going to be equal to V. What is the V we have found out? It is 2.2633. Across which resistor I am finding out? It is 4.7 kilo ohm. So it is 4.7 to 10 power minus 3, which gives us 0.4816 into 10 power minus 3. Right? So we are getting it to be 0.4816 milliampere. So therefore, the current through the 4.7 kilo ohm resistance is 0.4816 milliampere. So we do not apply current division rule to find the current across a resistor because the source given to us is a voltage source. So we can directly apply voltage division rule since voltage source is given, and after finding the individual voltages, we will find the current by applying normal Ohm's law. I hope the problem is clear to you. Thank you.